Good morning, everyone. Vanakkam, Namaskar, Sat Sri Akal, Adab. All the medical aspirants who have appeared for NEET 2020 and have not got into their dream colleges, don't worry, we have a golden opportunity for you guys. Come and join our repeater batch, which is going to be started from 5th of November 2020. And this batch is going to be up till your NEET 2021. We at Avatar are experienced faculties from all over India, and we are going to provide you the best coaching, the best material, what you need to make your dream come true in the top medical institutes of India. So come and join our hands and make your dream come true. All the best.
Sound. Good morning, children. Good morning. Good morning to you. Good morning to one and all. So sorry for the delay for 10 minutes. So there is a small internet issue was there. Okay, no issue. So we will start today's session. So NEET 2022 2 years classroom program. Children, I want to tell you one thing. So for NEET, physics is very important subject, that already I told you. So to get good score in physics, we should learn from basics. We learn from basics. So if you are strong enough towards the basics, then application questions, HOT questions, high order thinking questions, everything you can solve easily. And one more thing, we are providing the best faculty, so best material, best infrastructure, best environment. So please join with us. We are going to start the new batch very soon. Who are coming first, for first 10 students, early bird offer, we are giving 50% of the discount. 50% of the discount, children. So please hurry up and join with us, encourage us. And one more important thing, during this corona time, so you people, you need not to go to other places. So you from your home, you can learn everything. We are providing all the materials, all the requirements, whatever you want. And especially here, the faculty is very friendly with you. So you have any doubt, don't hesitate to ask. We will clarify your each and every doubt. So doubt clarifying sessions are there. Study hours, Menti quiz, everything we will provide, beta. Everything we will provide. And who are watching, firstly, so today they are watching first time, so please subscribe and share, give your valuable comments in the comment box. So good morning to children. So can I start today's session, beta? Yes. So today's session we are going to discuss about acceleration. So last class we discussed about the average speed, average velocity, distance and displacement. Whosoever not attended the last class, so please go through that, and then you come to here and listen this. Acceleration. Not full. Okay. acceleration. So we will discuss today acceleration. Acceleration, you know very well acceleration. What is acceleration? Rate of change of velocity. Rate of change of velocity, acceleration is equals to change in velocity by time taken. Change in velocity by time taken. Rate of change of velocity. The time rate of velocity of an object is called acceleration. Acceleration is a vector quantity. Acceleration is a vector quantity. Direction is same as that of the change in velocity. So there are three possible ways by which change in velocity may occur. So you know change in velocity, for change in velocity is a vector quantity. The change in due to magnitude of the vector, magnitude of the velocity vector and direction and both. Okay. So for that, so acceleration, rate of change of velocity, okay, rate of change of velocity, we thrown one object from certain height, the freely falling body. So freely falling body is example for acceleration. Okay, as it is coming down, velocity increases. If you thrown one object vertically upward direction, velocity increases. So velocity increases. This is also acceleration. Acceleration means simply we can say rate of change of velocity. So rate of change of velocity means with respect to the time. As the time passes, change in velocity will be observed. Then the body is said to be acceleration. So then the body is said to be acceleration. So these are familiar to you. So then we'll go with the next slide. Yeah. So when acceleration will be there. So here three ways are there. So first way, what is that? When only direction of velocity changes. Direction of velocity changes. So direction of velocity changes in the sense what? Uniform circular motion. As the particle is moving along the circumference of the circle with a uniform speed, there is no change in speed. Okay, at every point the speed will be same, but acceleration is in the direction of change in velocity. So change in velocity direction is along the tangent. So tangent is keep on changing on the circumference of the circle, and acceleration is always perpendicular to the velocity. Okay, so change in velocity direction. So acceleration direction is in the change in the velocity direction. So why? So this is the first way. So next second way, what is the second way? When only magnitude of velocity changes. Only magnitude. For example, on the straight line. So this is the familiar example. Here 5, here speed 10. So next moment 15 speed. So 15 speed from each equal intervals of time, 5 to 10, 5 change, and again next second 15 minus 10. So if the body is moving with the uniform acceleration, when we can say the body is moving with uniform acceleration, there is a change in velocity. Equal amounts in equal intervals of time. So that is called acceleration. So only magnitude, motion under gravity, freely falling body is starting speed. So what is the starting speed? U is equals to 0. After 1 second, the velocity became, so V is equals to U plus AT, U 0, A become G value suppose 10. So time 1 second. So velocity after 1 second it will become 10 meter per second. After 2 seconds, so the velocity becomes 10 into 2 after 2 seconds. Then it will become, velocity becomes 20. Next after 3 seconds, so V is equals to 0 plus 10 into 3. So 10 into 3, that will be 30 meter per second. U is equals to 0. Freely falling body, initial velocity is 0. While coming down, a motion under gravity. The body is falling due to acceleration due to gravity. That's why A can be taken plus G. Okay, A can taken plus G. Okay, beta. So next one, when both magnitude and direction of velocity changes. Okay, there is a change in velocity due to magnitude and direction. Okay, due to magnitude and direction. So acceleration has two components. One is perpendicular to velocity, another one parallel to the velocity or anti-parallel to the velocity. So best example is a projectile. So projectile motion. In that, so two components are there, horizontal component and vertical component. Horizontal component, the velocity remains constant throughout the motion. So vertical component, velocity changes. As it is going upward direction, velocity decreases, and again when it reaches to the maximum height, while falling down, coming down towards the down, velocity decreases. So it is called acceleration due to gravity. Okay, so here the direction as well as magnitude, both are changes, yeah beta. So next, dimensions. What are the dimensions? Acceleration is equals to velocity by time. So velocity, dimensional formula, Lt power minus 1 by t. So L into t power minus 2. Acceleration is equals to Lt power minus 2. So then SI unit. What is SI unit? Velocity meter per second by time second. So meter per second square. So this is SI unit. And what is the CGS unit beta? CGS unit is centimeter per second by second, centimeter per second square. So this is the unit for acceleration. Okay, this is the unit for acceleration. As like velocity, so acceleration also different types of accelerations we have. Okay, what are the accelerations? So quickly we'll discuss. So what are the accelerations? So here uniform acceleration. So first point is uniform acceleration. So what is uniform acceleration, non-uniform acceleration and average acceleration? Okay, so if acceleration is varies, then average acceleration comes into play, and uniform acceleration, when we can say uniform acceleration, see children, most of the children feel difficulty. Okay, they will get confused. Uniform acceleration, uniform motion. Okay, so uniform motion means constant velocity or constant speed. Uniform acceleration means what? Constant acceleration. So there is a much difference is there. Please note it down. Uniform acceleration. A body is said to have uniform acceleration if magnitude and direction of acceleration constant. So again I am repeating, uniform acceleration. What is uniform acceleration? A body is said to be uniform acceleration if magnitude and direction. Okay, so magnitude and direction. So magnitude of the acceleration is 10, throughout the motion is 10, and it has only one particular direction, such type of motion is called uniform acceleration. Okay beta, uniform acceleration. So here they have given one example. A particle is moving with a uniform acceleration. It does not necessarily implies that particle moving in a straight line. So projectile path, so projectile motion is not only in straight line. Okay, so in projectile path, the path followed by the particle is parabola. The path followed by the particle will be parabola like this. So from starting point, from origin to maximum height, velocity decreases. So there will be change in magnitude as well as direction. From maximum height to the ground, again there will be change in velocity, magnitude and direction. Okay, so here the particle is not followed straight line. So it may be any path. Okay, it may be any path, may be straight line path or curvilinear path. Okay beta. So what is uniform acceleration, children? Constant acceleration means throughout the motion same acceleration means what? Same change in velocity, same change for every intervals of time. Clear? Non-uniform acceleration. So next one is non-uniform acceleration. So what is non-uniform acceleration? A body is said to be non-uniform acceleration. So means if magnitude and direction and both can change. Okay, magnitude and direction and or both can change. Okay, so circular path will take. So this is a circular motion. So this is the center of the circle. This is the starting point. Here speed 5. Here speed is 10. Here speed is 15. Here speed is 20. So this body is said to be accelerated body. So why? Because so there will be change in velocity from here to here, again change in velocity from here to here, again change in velocity from here to here. So every time that magnitude how much changes? 5 units increment is there. This is increasing velocity gradually. Okay, increasing velocity gradually. So due to magnitude there is a change in velocity. Okay, so due to magnitude there is a change in velocity, as well as there is also change in velocity due to direction. So direction is along the tangent. So tangent also changes. So means this is the example for both. So if you take the straight line path, in the straight line path, So here speed 10, here speed 20, here speed 30, here speed 40. This is only due to change in speed. There is not due to change in direction, not due to change in direction, so means only magnitude 10 to 20, 20 to 30, 30 to 40, but fixed direction in circular path. So another example, so here speed 5, 5, 5, 5. So you already studied this uniform circular motion. In uniform circular motion, so there is no change in magnitude, but there is a change in direction. So due to direction, the particle have acceleration. So next, average acceleration. Okay, as like average speed is equals to change in average velocity, change in displacement by time taken. As like average acceleration is equals to change in velocity by time taken. So change in velocity, what is change in velocity in the given time interval? V2 minus V1, V2 minus V1, V2 minus V1. Okay. So next slide. Yes. In this slide, what is given? Look at here once. What is given? Instantaneous acceleration, as like instantaneous speed, instantaneous velocity at a particular instant of time. See in this diagram, at this point what is the direction? At this point what is the acceleration of the particle has? At this particular time of position, particular time of instant, particular time and instant, what is the acceleration of the body has? That is what? Instantaneous acceleration. So look at here, in this, for example, at this point V1 speed, at this point V2 speed, at this point V3 speed. Okay, so this is V3 is the instantaneous speed. Okay, V3 is the instantaneous speed. Here V2 is the instantaneous speed. Okay, here V1 is the instantaneous speed. Okay, the change in velocity gives instantaneous acceleration. Change in velocity gives instantaneous accelerations. Okay, then go to next slide. Yeah. Next, here some important points regarding the acceleration. Okay, uniform circular motion theta is equals to 90 degrees. In uniform circular motion theta is equals to 90 degrees. So acceleration direction this, so this is the velocity direction. So what is the angle? 90 degrees. Next, if a force F acts on a particular mass by Newton's second law, according to Newton's second law, force is equals to mass times acceleration. So therefore acceleration is equals to force by mass. So next, from the definition of acceleration, acceleration is equals to change in velocity dv by dx, dv by dt. By definition dv by dt, acceleration is equals to dv by dt. So next, what is v? So dx by dt. What is v? Dx by dt. So dx by dt substitute here. So dx by dt substitute here, a is equals to d by dt of dx by dt. So okay, so we can write this one as d into d square x by dt square, d square x by dt square. So acceleration, what is acceleration? Change in velocity by time taken. So what is velocity? Change in position by time taken. So right here v value, what is v value? Dx by dt, d by dt of dx by dt, d square x by dt square. So acceleration is equals to d square x by dt square. So next, if velocity is given as a function of position, okay, here the velocity is the function of time. Okay, velocity is the function of time. So now here what is telling, if the velocity is given as a function of position, so then how to write the acceleration? Acceleration is equals to a v dv by dt. Okay, dv by dt. So what I am doing here? So I am multiplying with dx divided by dx. Okay, so dv by dx I am writing at one place, dv by dx I am writing at one place. So remaining term I am writing it another place. So dx by dt, according to the definition, that will be v into dv by dx. v into dV by dx. So this is also very important formula beta, so you please note down. So then we'll go for next slide. Yeah. So in this slide, a particle is accelerated for a time t. A particle is accelerated for time t1 by acceleration a1, for time t2 by acceleration a2. Then average acceleration is equals to, this is the formula, a1 t1 plus a2 t2 by t1 plus t2. A particle, so in t1 time interval acceleration is a1, in t2 time interval for t2 time acceleration is a2, then average acceleration is equals to a1 t1 plus a2 t2 by t1 plus t2. Next slide. Yeah, so this is very important one. Now you see better. In this, what is given actually? What is given? M1 and M2. M1 and M2. Okay, M1 and M2 are the two blocks. M1 and M2 are the two blocks. Yeah, so M1 and M2 are the two blocks. So on two blocks, the force is acted separated individually. Okay, so same amount of the force, F force is acting on M1 and another again same amount of the force is acting on M2. So this force leads to produce the acceleration A1 here, and here the acceleration is A2. Okay, so now they combine together, M1 and M2 combine together and applying the same amount of the force. What is your resultant? What is your resultant? You know F is equals to mass times acceleration m into A1. From here, from this diagram, we can also write F is equals to m2a2, here m1 a1. On m1 to produce acceleration a1, F force is required. On m2 to produce a2 acceleration, F force is acted. In this, what is asking, the same amount of the force is acting on combined block. Combined block means what is the mass? This time m1 plus m2. Okay, so let me write this time F is equals to m1 plus m2 into acceleration. So that acceleration we don't know how much acceleration will be generated. So from this we can write. Okay, so from this we can write. Okay, so F means what? Okay, F means 1 by A. Okay, so this A is on this side. F is equals to 1 by. Okay, so do one thing. F by A is equals to. Okay, F by A is equals to M1 plus M2. M1 plus M2. So what is M1 children from this? M1 is equals to F by A1. By using this expression, M2 is equals to F by A2. F by A2. Substitute here, write over here. F by A gives rise. F by A is equals to M1. Substitute M1 value. M1 is equals to F by A1. F by A1 plus M2. What is M2? What is M2? F by A2. F by A2. Okay, children. So in this, what is common? Simple. What is common? F is common. So taken out. So F taken common and gets cancelled on both the sides. So what you will get? 1 by A is equals to 1 by A1 plus 1 by A2. So if you simplify more, so A1, A2 is the LCM. A1, A2 by A1 gives A2 beta. Then A1, A2 by A2 gives A1 children. So my dear children, so please note down this. 1 by A is equals to A1 plus A2. Okay, A1 plus A2 by A1, A2. A1 plus A2 by A1, A2. So we want A value, right? So do reciprocal on both the sides. Then you will get A1, A2 by A1 plus A2. So this is your required answer. So to produce the acceleration. Okay, so to produce the acceleration. So it means same force acting on the combined blocks. Then So this much acceleration will be generated. This much acceleration will be generated. So go for next slide. So okay, so then go for next slide. So what is the next slide? We'll see. Yeah. Next, as like, so acceleration is a vector quantity. So acceleration can be positive, can be 0, can be negative also. Okay, acceleration can be positive, can be negative, can be 0 also. So when it will be positive? When it will be positive? In general, if velocity increases, okay, if velocity increases, we taken as positive. Freely falling body, motion under gravity, okay, motion under gravity. A train is leaving from the platform, so that is positive. 0, when it is 0, if the particle is moving on a straight line with a constant velocity, acceleration is 0. So next, negative, when acceleration is taken as negative. So vertically projected body, yes beta. So vertically projected body, what happens? So this is moving against the gravitational force, so velocity decreases. So velocity decreases, acceleration can be taken negative direction. Okay, bus is moving, suddenly the bus driver applies the brakes, so it is retarding force. Retarding force leads to retardation. Clear beta? Yeah, these are all the points you know. Next one, for motion of a body under gravity, that acceleration can be equal to acceleration due to gravity. Acceleration due to gravity value, you know, experimentally they found to be g is equals to 9.8 meter per second square, or if you convert into centimeter per second square, so 9.8 meter per second square is equals to 9.8 into centimeter, convert into centimeter, 100 centimeter by second square. So 9.8.0 gets cancelled, 98 into 10, 980 centimeter per second square. So this is your CGS value of acceleration due to gravity, 9.8, okay, 9.8. Children, so this is very, very important. In most of the numericals, acceleration due to gravity will be there, okay, and most of the children repeatedly they are asking that sir, should I take 9.8 or 10, okay, so 9.8 or 10. So in the given numerical, if they mention the g value, take that value. They will mention sometimes 9.8 or 10, then you take that value. If they do not mention anything, they did not describe about the acceleration due to gravity, they did not talk about anything about the acceleration due to gravity. So children, so please you take that time acceleration due to gravity value as 9.8 meter per second square, okay. So these are the important points regarding acceleration, okay. So these are the basics, you know. So then we will discuss some important numericals based on this concept. So please, if you know the answer, you can chat with me, you can tell me the answer also, okay beta. So who are watching now live, so you can also tell me the answer, so I feel very comfort, okay. Yeah, so what is the first question? The displacement of a particle. So the displacement of a particle moving in a straight line is given by this relation. What is this relation? S is equals to 2t square plus 2t plus 4, where S is in meter and t is in seconds. So find the acceleration of the particle. So very easy question, children. So S is equals to 2t square plus 2t plus 4. This is a given expression, right? Okay, so time derivative of displacement is velocity. So we should write v is equals to ds by dt. So d by dt of S, what is S? 2t square plus 2t plus 4. So you know the derivations, already we did this. So we will little fast will go. So 2 taken out. So d by dt of t square. So d by dt of t square value 2t plus next one. So d by dt of 2t, okay, 2 taken out now, d by dt of t is 1, okay, is 1 plus for constants it is 0. So S is equals to 2t square plus 2t plus 4, V is equals to ds by dt, d by dt of S, S value is given 2t square, okay, 2t square, so 2 into, okay, so 2 into t square value, 2 into 2t, okay, 2 into 2t, so 2 into 2t 4t plus 1, okay, 4t plus 1. Next, but is not asking the velocity, is asking the acceleration, okay beta. So is asking the acceleration. So what is acceleration? Time derivative of velocity. So time derivative of velocity dv by dt. So dv by dt, okay, so d by dt of v, what is v here? 4t plus 1, okay, so d by dt of 4t plus d by dt of 1, so d by dt of 4t is equals to 4 into dt by dt plus for constants 0, so dt by dt value cancel, then acceleration is equals to 4 meter per second square. So what is your answer beta? 4 meter per second square. So please note down, I will give 10-second time. Okay children? Yeah. Yeah, go to next slide. दूसरा सवाल देखो. Here what is given children actually? The position of a particle varies as this function, acceleration of the particle will be 0 at a time equals to, at what time that acceleration becomes 0? So at what time that acceleration becomes 0? Very easy. So same story, a t square minus b t cube, okay, a t square minus b t cube. What is v? V is equals to dx by dt, okay. So d by dt of this, so d by dt of a t square minus b t cube. So a taken out, a is constant, d by dt of t square value 2t minus b into, so d by dt of t cube, so d by dt of t cube is 3t square, 3t square. So this is 2a t minus 3b t square, this is the velocity, okay. So what is asking? Acceleration. Acceleration is equals to dv by dt. So d by dt of, again we should derive this with respect to the time. So 2a t minus 3b t square, 3b t square. So a is equals to d by dt of 2a t gives 2a minus, so d by dt of 3b t square. So 3b into t square derivative 2t. So 3b into 2t 6bt, 6b into t, 6b into t. So according to the question. So what is telling beta here? What is telling? Simple. Acceleration of the particle will be 0 at a time t is equals to 0. At time equals to what? So acceleration will be 0. Acceleration will be 0. So equate acceleration is equals to 0, 2a minus 6b into t. Okay. So 6b into t, send that side, is equals to 2a, then time is equals to 2a by 6b. So according to the option we'll go with, so 2a by 3b is there, so 2a by 3b is there, so 2 1 times, 2 3 times, so answer is a by 3b, a by 3b. So this is your answer, a by 3b, a by 3b, okay, a by 3b. So what is your answer children? Then option C. So option C is the right answer. So please note down. Okay. Completed? Then I go with next slide. Yeah. So next, problem number 14. Yeah, the displacement of the particle is given by, the displacement of the particle is given by, the displacement of the particle is given by y is equals to a plus bt plus ct square minus dt power 4. See, that's the same, based on the same model I am explaining to you more numericals because of your perfection. Okay. So y is equals to a plus bt plus ct square minus dt power 4. Okay beta? Velocity, derivation of this for constants 0 plus b plus 2ct minus 4 dt cube. This is velocity. Okay. So what is asking? Initial velocity. Initial velocity means when it will initial velocity, you will get initial velocity means starting velocity. Starting velocity means t is equals to 0. Correct. So t is equals to 0. Right in this, v initial is equals to right, t is equals to 0. So b plus 2c into 0 minus 4d into 0 cube. So therefore v initial velocity is equals to what? B. So b is the answer. Okay. So b is the answer. So that is for velocity. So he is also asking the acceleration. So he is also asking the acceleration. For acceleration is equals to dv by dt. So dv by dt for so d by dt of this much. So d by dt of this. So d by dt of constant of b is 0. For constant derivation 0. So next 2c minus 4d into t cube. So 4d into t cube 3t square. So 3t square into 4d. So 3t square 3 into 4d 12 dt square. Okay. So this is acceleration. So again initial acceleration. Initial acceleration in the sense put t is equals to 0. So when you put t is equals to 0, a is equals to what, Nana? 2c minus 0. So therefore a is equals to 2c. So required answer, the answer is b comma 2c. B comma 2c. So this is your answer. Please note down. Yeah. So completed, then we'll go with next slide. So what is the next slide? Yes. So this is a question. So this is another model. Yeah. Look here. The relation between time and distance. The relation between time and distance is given by this expression. Time is equals to ax square plus bx, where alpha comma beta are constants. The retardation is asking. So retardation is nothing but acceleration. So but there is a difference between acceleration and retardation, means what? That retardation is in opposite direction of motion. So in general we call negative acceleration. So what is negative acceleration is asking. Okay. Yeah. So what is the given expression? So that again we'll write again. So t is equals to alpha x square plus beta x. Okay. Alpha x square plus beta x. So differentiating time. So here differentiating, because time is given, no. So differentiating this with respect to the position, dt by dx. Okay. So dt by dx. So d by dx of alpha x square plus beta x. Alpha x square plus beta x, which implies, so d by dx of alpha x square, alpha is constant, d by dx of x square will be 2x. 2x plus beta into dx by dx, that will be 1. That will be 1. So finally, what is your answer? dt by dx is equals to 2 alpha x plus beta. 2 alpha x plus beta. So this is dt by dx value. Okay beta. So dt by dx value is this much, then dx by dt you know velocity. So why? I will do reciprocal. So what is that? 1 by 2 alpha x plus beta. So this is, let me write equation number 1. Okay, let me write equation number 1. Now acceleration. So acceleration in terms of, okay, velocity taken in position of a function, velocity taken in position of function. So a is equals to v into dv by dx. Okay, a is equals to v into dv by dx. So this is the expression. Today, few minutes back we discussed this. A is equals to v into dv by dx. Okay, so write in this, a is equals to, what is v? What is v? Let me write v only. Okay, let me write v only because answer is given in terms of v. Okay, dv by dx, dv by dx. So d by dx of v, d by dx of v. What is v? 1 by 2 alpha x, 1 by 2 alpha x plus beta, 1 by 2 alpha x plus beta. So a is equals to v into, this will be, see, so d by dx of x, 1 by x. Okay, so this is some function, something. Okay, so this is how much? This one 1 by x means that is nothing but x to the power minus 1, right? 1 by x is equals to x to the power minus 1. So now d by dt of x to the power n. So d by dt of x to the power n is equals to n into x to the power n minus 1. What is the n value here, children? N value is minus 1. So minus 1 into x to the power n minus 1, n minus 1, minus 1, minus 1, according to the formula. So minus 1 into x to the power minus 2. So finally we will write minus 1 by x square, minus 1 by x square. So here instead of x, what is there? 2 alpha x plus beta. Okay, so 1 by minus 1 by 2 alpha x plus beta whole square. Okay, so this is the differentiation of this. Next again we should differentiate this value. Okay, so d by dx of 2 alpha x plus beta, 2 alpha x plus beta. So that will be minus v upon 2 alpha x plus beta whole square into, so d by dx of 2 alpha x plus beta value 2 alpha. Okay, 2 alpha. So 2 alpha. Now finally we will write minus 2 alpha v at one place into 1 by 2 alpha x plus beta whole square, beta whole square. So what is from equation number 1? 1 by 2 alpha x plus beta is equals to v square. So then this term will be equals to my v square. So what is your answer? Finally 2 alpha v into v square. So my dear children, the final answer is minus 2 alpha v cube, minus 2 alpha v cube, minus 2 alpha v cube. So retardation, so negative, so magnitude we should take 2 alpha v cube. 2 alpha v cube is first answer. 2 alpha v cube is first answer. Okay. Yeah, next question. Okay, so displacement of a particle is directly proportional to square of the time, then the particle moving with the. Displacement of a particle is directly proportional to square of the time, then the particle is moving with the. Okay, then the particle is moving with the uniform acceleration, uniform variable acceleration, uniform velocity, variable acceleration but uniform velocity. Okay, so what is asking? Yeah, okay. The displacement of the particle is directly proportional to the square of time. So S proportional to t square beta. If S proportional to t square, to remove the proportional we will keep one constant, that is the proportionality constant. S is equals to k into t square, k into t square. So now differentiate this, ds by dt. ds by dt is equals to k into 2t. Okay, k into 2t. So ds by dt is v is equals to 2kt. Okay, v is equals to 2k into t. V is equals to 2k into t. So this is a velocity. Okay, velocity is given, uniform velocity given. So variable acceleration but uniform velocity. So is it uniform velocity? No. So velocity is changing with respect to the time. Okay, so it is a function of time. So it's not uniform. So we'll go with the acceleration. Okay, so acceleration is equals to dv by dt. dv by dt. So d by dt of v. What is v? 2kt. So 2k is constant taken out. So into dt by dt. So dt by dt cancel. Acceleration is equals to tk. 2k. So what is your answer, beta? Acceleration is the acceleration is the function of time? No. So acceleration is constant. So acceleration is constant means what is your answer? It is uniform acceleration. Okay, it is uniform acceleration. Okay, beta. So today we have discussed about acceleration, what is acceleration, and some important points in competitive examination. What is acceleration, positive acceleration, negative acceleration, zero acceleration, what are the units, and based on the acceleration few numericals we discussed today. Okay, so we will go slowly. Okay, because this chapter is very important for your basics, children. So please join with us. So November 15th is the last date. So before that you please enroll. So you will get 50% of the offer. So please utilize this. And if you like this video, please subscribe and share to your friends and your relatives, known persons. So please don't forget to subscribe and share. So in the next lecture we are going to discuss about important topic, that is most of the questions. Okay, from this topic most of the questions to be asked for every competitive examination, so those are graphs. Okay, graphs, position time graph, velocity time graph and acceleration time graph. So based on the different types of graphs, how the numericals to be asked. So everything will be discussed in this. Thank you for attending my session. So please subscribe and forward to your friends. Thank you so much.